Hello everyone, welcome to Payment Tech Media. This video is another example of IPv4 Classless Subnetting. Stay tuned and let's have a look. Now in this example, let's say they gave us another Class C network address, but this time asking for different number of available IP addresses. For example, the network address, let's say 192.168.1.0 and default subnet mask 24. So it's a 255, that's Class C, right? So default subnet mask for Class C, 255.255.255.0, and they said we need 90 available IP addresses. So number of hosts, let's say 90. So previously we talked about counting right to left, starting with 2 at the bottom. We can count the number of hosts, 2, 4, 8, 16, 32, 64. Can we stop here? No, they're asking for 90 hosts, so 64. If we again continue doubling, right? 128. That's it. So this is perfect. 128 minus 2, 126. So 126 meets our requirements. They're asking for 90 hosts. We're not wasting too many IP addresses. 126, that's perfect. So we just need to borrow one block, right? So originally the default subnet mask, our cut line is here. So we have all the 24 bits turned on and the last 8 bits turned off. But asking for 90 hosts, when we do the subnetting, you see, this is the original cut line, the default subnet mask for Class C. We moved it to the right. That's known as subnetting. We will talk about supernetting, where we move the cut line to the left. That's supernetting. So subnetting, it's basically moving the cut line to the right, basically borrowing from the host bit and turning it on to be part of the network bits. So this is known as the subnet bits. These are the network bits, subnet bits, and of course zeros, host bits. Okay, so what is our new subnet mask and the CIDR notation? The CIDR notation, it's not 24 anymore, and the subnet mask, it's not 255.255.255.0 anymore. So the CIDR notation is 24 plus 1, right? So it's 25. And the subnet mask is 255.255.255, 1 bit borrowed, right? So it's 128. 128. So how many subnets do we have? The number of subnets going from left to right, right? Starting with 2. So it's only basically 2 subnets. Or we talked about this formula, the number of subnets, it's basically 2 to the power of subnet bits. And the number of hosts, 2 to the power of host bits, minus 2. Which again minus 2 because of the network address and a broadcast address. So that's what we see here, minus 2. Or in other words, if we count going from right to left, starting with 2, 2, 4, 8, 16, 32, 64, 128 minus 2, 126. These are the number of hosts. And number of subnets, it's only 1 bit here we have. So going from left to right, starting with 2. So 2, that's only 1 subnet. So that's basically gives us 2 subnets. And every subnet we will have 126 available IP addresses. Let's find out. So if we apply this formula, 2 to the power of subnet bits, how many subnet bits do we have? 1. 2 to the power of 1, it's 2. And 2 to the power of host bits, all the zeros is host bits. So we have 1, 2, 3, 4, 5, 6, 7. 7 host bits. 2 to the power of 7 minus 2. So it should be 128 minus 2, which gives us 126. So we will have 2 subnets with each 126 available IP addresses per subnet. And if we see it in action, so we have 192.168.1.0, that's our 0 network, 192.168.1.0 network. And this is the network address, here the broadcast address. Now what is the last bit that is turned on? This is the last bit turned on. What is the decimal value? 128, that's our network increment. So we are incrementing by 128 on the last octet. So here we have 192.168.1.128. If we continue incrementing by 128, we will have 192.168.1.128. 256. And again, I used different color. 256 not valid. So these are our two subnets. For the first subnet, what is the broadcast? Always broadcast is one less IP address than the next subnet. So if the next subnet is 1.128, one less IP address would be 1.127. So the broadcast address for this subnet would be 192.168.1.127. And the range, the first available IP address, 192.168.1.1, and it goes to 192.168.1.126. So 1 to 126, and here we can see 126 available IP addresses per subnet. How many subnets? Two subnets we see. This is subnet number 1, subnet number 2. And here, of course, not valid, because if we continue incrementing by 128, we get 256, 256 not valid. In other words, it would be 192.168.2.0, because 256, it will be turned to 0 and add to the next octet to the left, so it will be 2, and that's a different network. We are on one network. Therefore, the CIDR notation of 25 gives us two subnets. Increment would be 128, and each subnet will have 126 available IP addresses. They did ask for 90 available IP addresses per subnet or per network, but of course the closest block is this one, which we are not wasting too many IP addresses, and we're still meeting the requirements, the minimum requirements. For the next subnet, the broadcast here would be 192.168.1.255. That's the last IP address, right? If we add one IP address, it will be 256. We don't have 256, so it will be 0, adding to this one, 2, 192.168.2.0, right? So which we see here. So that's the broadcast for this subnet. And the first usable is 192.168.1.129, because 128 is network address. So one IP address to this network address, that's the first available IP address, which is 129. And it goes to 192.168.1.254, 254, one less IP address than our broadcast. So 1.129 to 1.254, that's a total of 126 IP addresses. Therefore, again, with the CIDR notation of 25, we will have 255.255.255.128 subnet mask. That's a classless subnet mask. It's not a default subnet mask. We will have two subnets, and each subnet we can have a total of 126 available IP addresses per subnet. I hope this video was helpful. Thank you so much for watching. If you have any question, please leave it in the comment section. And if you haven't subscribed to our channel and you want to see more tech videos like this, please consider subscribing to our channel. So thanks again, and have a good day.